This is the gyroscope. Okay, if you understand this, you understand all the instruments, you understand all the properties of gyroscope. Whatever happens to this lattu, top, Beyblade, it's exactly what gyroscope is. Hello ladies and gentlemen, your captain speaking on flight deck. My name is Captain Surinder Singh. Welcome aboard the plane talking. Sit back, relax and enjoy your journey. So now we will take on gyroscopic instrument. Now before we start gyroscopic instrument, let's understand what is gyroscope. So anyone? So now it, yes, gyroscope. What is gyroscope? एक मिनट हाँ जी तसी दसो.
Device used to measure the orientation of an object with respect to its rotation or angular velocity.
इतनी इंग्लिश थोड़ा धीरे दोबारा बोला. ओके गुड. हाँ जी आप बताओ. ये बेटा कहाँ से ज्ञान लेके आता है? चैट जीपीटी से. ओके या सो you're generally all of you are right. Okay, this is gyroscope. The simple understanding of gyroscope, if you understand this, ये क्या कहते हैं इसको? What you call it? टॉप, लट्टू, बेब्लेड. बेब्लेड से तो खेली होगी आपकी जनरेशन. चड्डी पहन पहन के स्टेडियम ले लेके भागे होगे. पतीले, कटोरियाँ, कढ़ाइयाँ. No? Yeah, this is simple understanding of a gyroscope. That's how I started teaching in 2004, way back. So this is the gyroscope. Okay, if you understand this, you understand all the instruments, you understand all the properties of gyroscope. Whatever happens to this lattu, top, Beyblade, it's exactly what gyroscope is. Anybody can tell me what is peculiar about this lattu? Yeah, it is maintaining its axis of rotation as long as it is rotating. If I give you this top like this, what will happen? Will it maintain its axis? What will happen to this? It will fall. What do you call it? It will topple. So it is exactly the same terms which is used in gyroscope. You will see topple. What is topple? It has lost its axis. But as long as it's rotating, it will maintain its axis of rotation. Now what happens when you put this lattu or gyro top in rotation because of friction? What happens? It slows down because of friction and then eventually it topples. This is the property of any rotating mass. Example, bicycle. If your wheels are stationary, they are not maintaining its axis, you fall. But when you put them in rotation, what happens? They maintain their axis of rotation and it becomes easy for you. So any rotating mass has got property of continue to maintain its axis of rotation. Normally we call it as inertia, resistance to change. A body will continue in the state of rest or uniform motion unless disturbed. Is exactly. But for gyroscope or for the rotating mass, we don't use this term inertia. The meaning is same, but we call it rigidity. How rigid it is in its axis of rotation. So as long as it is rotating, this axis is maintained. So wonderful thing. We will see how this all the instruments are made out of this lattu, and I will show you the instrument where actually inside is a lattu, a top. So when you talk about rotating mass, okay, we call it rotor. So there are two terms which are used for any rotating object. One is axis, what is plane. For the lattu, top, Beyblade, your axis is vertical, but which direction it is rotating? Horizontal plane. So plane is horizontal. Similarly, in this axis is horizontal, here the axis is vertical. But what is the plane? The plane is vertical plane. Understood these two terms? One is axis of rotation, one is plane of rotation. When I arrange this setup, something like this, we call it gyroscope. But remember, the main thing is this rotating mass. What is the property? It will maintain its axis of rotation as long as it is rotating. So I put in rotation either by electrical motor, or I put vacuum pressure, or basically air pressure. Like you have seen water wheel. On water wheel, when the water impacts, it rotates. So in the aircraft also, initially they developed vacuum driven or air driven. Air driven means the air comes at high velocity, it impinges on the rotor, and you put it into rotation. So let's say I take this gyroscope, or rotating mass for that matter, let 2. As long as it is rotating, what will happen to this axis? It will maintain. Imagine this setup is in the aircraft. Aircraft may pitch up, pitch down, do whatever in any axis. What will happen to this? It will maintain this axis of rotation. And then we create this instrument, we will see that. So you can have horizontal axis gyro, or you can have vertical axis gyro. So when you talk about rigidity, it is a property of rotating mass where gyro axis maintain its position as long as it is rotating. That is called rigidity, but simply speaking it is inertia. So in any gyroscope we have axis of rotation. So in this case it is horizontal axis, and then you have plane of rotation. In a apparatus which normally people refer to as gyroscope, the main thing is this rotating mass. Now I create a setup, I put frames around it, which has got freedom of movement in all 3 axes, which you were telling. It has got freedom of movement in all 3 planes. So this rotor, obviously we refer it as rotor, and this setup of frames, we don't call them frame, we use the term called gimbal. How rigid my axis will be. Okay, so rigidity is given by SI by F. S is speed of rotor. The faster it is moving, the axis will be more stable, rigid. That's what happened in your LUT2 or top. Okay, with the time what happened? Because of friction, the rotational velocity reduces, it no longer remains rigid, and eventually it topples. I is moment of inertia. Moment of inertia is any rotating mass. Okay, we refer a term called moment of inertia, the ability to maintain its position of rotation. It is given by proportional to how much is the distance, how much is the mass. So that's why the mass, the farther it is, more will be the rigidity. This is your radius, so that is R, and how much is the mass. So even in the Beyblade, remember, you had a metal ring. Where was that metal? It was a ring, because what you have done, you have concentrated mass away from the center. Okay, the farther the mass concentration is, more will be the moment of inertia. Wait, I will show you. So this is Beyblade. So this metal, if you see, this is inside is plastic. Where the metal ring is? It is on the side. It is heavy from the side. So we have seen property of a rotating mass. It maintains this axis of rotation. There is another property of a rotating mass which is called precession. Actually speaking, opposite of rigidity. Rigidity, we saw it is a property of a rotating mass to maintain its axis. Precession is exactly opposite. How a rotating mass will shift if it is applied with any external force. So this word normally people confuse with precision. The precision is a different word. Precise, accurate. Precision approach. It is precession. And the word is originated from word precess. Precess means shifting. So now this property of a rotating mass is that, let's say if this is not rotating, wherever you apply the force, let's say I apply this force will act here. What will happen? This will tilt, it will shift gyro axis. If I apply this force here, it will shift here. That's what happens. But in rotating mass, this shift doesn't take place this way. If I put it to rotation and this is rotating, wherever I apply this force, it acts 90° ahead in the direction of rotation. So, if this is rotating, wherever you apply that force, it shifts 90° ahead. So, let us say if I apply this force, it will shift 90° ahead, and that is how this shift will take place. If you apply this force, it will tilt this way. Why? Because this force will act 90° ahead. So, that is what happens in any rotating mass. It is rotating, you apply this force here, this force will not act here, this force will act down, and that is how it will tilt ahead in the direction of rotation. Best example is that Beyblade. If it is rotating, if I hit it, it does not go straight, it will goes wherever you apply force, it will go shift 90° ahead, and that gyro axis will shift. Wait, let me see. Okay. So, let us see. And if I tap it somewhere, it goes on the right side. Can you see? If इसको low RPM पे rotate करते हैं अभी, then you will see more. Yeah, you saw at that low RPM how it went. So, in a rotating mass, when you applied the force, the gyro axis will shift by the force acting 90° ahead in the direction of rotation, not where you applied the force. It is rotating, whichever direction it is rotating, you apply force, act 90° and will cause gyro axis to shift. At higher RPM, it was not shifting much, but at lower RPM, in fact, if you have a Beyblade, you can see it. At low RPM, if you tap a little, it goes more. At high RPM, the rigidity takes over. So, the formula is also opposite. So, F is the external force, S is speed, I is moment of inertia. So, we use this rigidity and precision to create those instruments. We know rigidity, that if you put a rotor in rotation, it will maintain its axis of rotation. So, how magnetic compass works? There is a magnet inside which always point towards magnetic north. So, let us say if you shift that magnet, what will happen to that magnet? It will again align with the magnetic north. I use the same property of a rotating mass. Let us say I put this mass into rotation. Now, I align with the magnetic north. You align with the magnetic north, so what will happen? The gyro axis will maintain wherever you have maintained. That becomes your DGI, directional gyro indicator, in the aircraft, in the cockpit. So, that is what you do. In Cessna 152, 172, you switch on, start up the aircraft, you see the magnetic compass. Gyro does not know where the north is. Either at the time of takeoff, you know the runway direction, you align there, or you look at your compass, you align it. Now, what will happen? It will stay there. You have created a wonderful piece of equipment in the aircraft that is called DGI, directional gyro indicator. Let me show you. In the aircraft, you have this DGI. It is showing you what direction you are flying, 230. Now, inside is, you have just a horizontal axis gyro, nothing else. So, the basic property of a rotating mass, I have created an instrument which shows me which direction I am flying. That is your DGI. So, what do? You start up the aeroplane. When the RPM reaches, after some time, you have a knob here, push, yahan likha hai. You can see this push written here. So, you push it, you look at the magnetic compass and you align with the direction. So, when you do this, what you are doing? You are aligning this gyroscope with the magnetic north. So, when you aligned it, what will happen? This will stay there, and whichever heading you are flying, it will show you heading. After few turns or certain maneuver, what happens? This will, gyro axis will shift. So, that is what you do. You level out the aircraft, again you look at your compass, again you show where the magnetic north is, and that is your DGI, simple property of a rotating mass. Second thing you need is artificial horizon. Artificial horizon is what? So, this is your DGI. Inside this DGI is what? Just a horizontal axis gyro. In fact, that is the working of DGCA. This instrument, this is called artificial horizon. You have a natural horizon. What is the property of a natural horizon? Basically, it always remains horizontal, correct? If you put on bank to one side, the horizon remains horizontal. That's why the name is horizon. This is your turning right. You turn left. If you pitch up, what you will see? You will see more of sky. If you pitch down, you will see more of ground. So basically, it remains horizontal. So you want to create, when the natural horizon is visible, you can look outside and you can fly. But when you don't have natural horizon, you create inside artificial horizon or attitude indicator. So you have a natural horizon, in the cockpit you have artificial horizon. What is inside? You want, whatever you do, this reference should remain always horizontal. That's what you want. So you want this reference to be always horizontal. Aircraft pitches up, this will go down, you will see more of sky. You pitch down, this will go up, you will see more of ground. When you put on bank, any side, so this is basically remaining always. That's what you want? Wonderful, no problem. We use property of a rotating mass, where the gyro axis maintain its position. So I create a vertical axis gyro, I put it in rotation. So what will be the property? It will maintain its axis of rotation, always vertical with respect to Earth surface. So you take a gyroscope, vertical axis, you put it in rotation, you keep it vertical, and you create a horizontal reference like this. As long as this axis is vertical, what will happen? The reference which you have created will always remain horizontal. You pitch up, pitch down, do whatever. If this axis is vertical, what will happen to the reference which you have created? Rigidity, another instrument, wonderful instrument. Here it is. You have a vertical axis gyro, and with this you have created some gimbals, frames, and you have created this. As long as this axis is vertical, what will happen to this? This will remain horizontal. So rigidity, another property. So you have created another instrument which is just a rotating mass. As long as this is vertical, the reference system, if this topples, this will also topple. Understood? Because your gyro axis is shifted, now this thing will topple. You put it against it, it will remain. So the reference which you have created, it is always remains horizontal by simple property of rigidity. So these two instruments use the basic principle of rigidity. So artificial horizon, you can actually visualize a top. So as long as this top is vertical, this axis will remain horizontal. So there are various type of gyroscopes. Basically, how you control the gyro axis, it becomes classification of gyroscope or types of gyroscope. There are 4 types of gyroscope which exist. We have space gyro, we have earth gyro, we have tide gyro, and we have rate gyro. It is tide. Earlier I used to dictate, write down types of gyroscope. Till one day I saw in a notebook, person had written. So that was the last. I stopped dictating, I write now. It is not टाइड बोल भी रहा हूँ, TIED, जाके थोड़ी देर बाद नोटबुक में देखता हूँ टाइट जायरो. Okay, it is, yeah, I also learned while teaching. So I learned, लिख दो शांति है. Okay, tide, gyro, and then you have rate gyro. We will see one by one each. Please copy this. So now let's see what are these 4 type of gyroscope. First is free or space gyro. As the name suggests, free means it has got freedom of movement in all 3 planes, and gyro axis is maintained with a fixed point in space. Now that you can choose anywhere, wherever you align it, it will maintain there. In fact, it was used for Apollo missions also. That is the time it got its name space gyro, because When you're flying in the aircraft, you need to know your sky and ground. But let's say if you want to use some reference in the space. Okay, that's why it got its name space gyro also, because wherever you align it, it will maintain this position. You align like this, it will maintain in this position. So that is used in INS, inertial navigation system, because what we do, we will see what is the navigation system. We switch it on, align it with the Earth's true north. Jahan geographical north hai, so that's what we align it. So what will happen to this gyro axis? It will maintain there, so I can use it for navigation, something like that. Inertial reference system. You saw that pitch indication, roll indication in the glass cockpit. If there was no moving part, you saw that you have to create a reference system. So that's what you do. You align the gyroscope with longitudinal axis, lateral axis and vertical axis of the aircraft. So you have aligned with the stationary, longitudinal, lateral and vertical, like this. Now if you pitch up, pitch down, what will happen? This axis will maintain there, so you can use it to create attitude indicator or artificial horizon for the glass cockpit. We will see the difference also. It is there in fact on my YouTube channel also. People don't know the difference between INS and IRS. They think both are same. No, they are not same. INS is for navigation, whereas IRS is for navigation as well as reference system, cockpit reference system. You need direction. Which direction you are flying? DGI. So that is also is your, wherever you align it, it points there only. Who decide where to align? That you decide. Wherever you decide, it will maintain its position. Next we saw Earth gyro. Again, it has got freedom of movement in all three planes, and gyro axis is maintained its position by force of gravity. So what gravity does? Always pull things towards the center of the Earth. You saw in artificial horizon, what do you want? You want gyro axis always to be vertical, because if it is vertical, your reference which you have created will be horizontal. That's what you want. So we control this gyro axis with the force of gravity. We will see when we will study about artificial horizon. That time we will see there is a pendulous unit. The pendulum works on the principle of gravity. Means if you shift something, what pendulum does? It comes back. So that is force of gravity, and we will see how that a pendulous unit is there, which basically keeps the gyro axis always vertical, because as long as this axis is vertical, the reference system which you have created will remain horizontal. So that is your Earth gyro, and it is used in artificial horizon or attitude indicator. Then we saw tight gyro. Again, freedom of movement in all three planes, and gyro axis is controlled by an external force. Where it happens? In DGI. You saw there is a gyroscope, horizontal axis, it is rotating, it is pointing in some direction. So what do? You had a knob. In the cockpit you have this knob. You rotate it. When you are rotating it, what you are doing? You are tying this gyro axis with the magnetic north, because tying means external force is what? External force is this knob. So gyro axis is maintained in its position by an external force. So that is external force. So it is used in DGI. And the last is rate gyro. It has got freedom of movement in two planes and gives indication in third plane. We will see how this is used in TSI and third coordinator, because this is the only instrument which works on principle of gyro precision. 1, 2, 3, all they work on rigidity, whereas this works on precision. So here it uses a rate, it uses at what rate something is happening. Clear on this? So in the next class we will see how artificial horizon works and how this axis is decided, how that artificial horizon, one is vertical, DGI is horizontal, so how these axes are decided. Till then, stay tuned. This is your captain speaking.